Good morning. Welcome back for that same chapter, that is insight into program execution. And today's topic is process management. In the last session, we came to know that how a source code program is converted into machine code and what are the different role of an operating system for program execution. Okay. So how the operating system handle all kind of execution of the program. In between that process, the first thing is the process management, in which today we will go for two things. One is the how memory allocated to a particular process and what are the different states of a process to be executed. So first go for the memory allocation. So as soon as the object code generated and the executable code handed over to operating system, the first task of operating system is to assign some memory or allocate some memory to that particular process or a group of processes for going for execution inside the CPU. So when we are going for allocating the memory, so generally a process is allocated these 5 different segments of memory. A single process have been allocated with these 5 different segments of memory. The first segment is a global variable and second segment is program code. So first we'll go for the program code. In case of program code, that is nothing than the binary code, all and each and every instruction of that particular program or process are stored in this specific section of the memory or this specific segment of the memory. The next segment that stored the global variable. Here I want to clear you something about the global variable and local variable. We'll go for the programming purpose. When we are doing programming at that time, you will clearly understand what is global variable and what is a local variable. Okay, for up to that, for a little bit of knowledge, we should know that the global variable will exist with the program until the program execution completed. That means from the starting of the execution of the program up to the end of the program execution, the global variable exists with the program. But in the other hand, the local variable are come in some instance of time with the program. That means as per of the requirement of the program, the memory will be reserved, and after using that particular variable or that particular value, the memory has been recollected from the operating system by the operating system. So this specific area is used for your local variable or the global variable that will exist with the program execution. Then two more things are there. One is the stack, another is the heap. As this area is for the global variable, likewise the heap is used for the local variable or dynamic allocation of memory. Dynamic allocation of memory is a term, or the dynamic allocation is a term that is used in the computer science. That means which is allocated instantly or which is assigned instantly to the computer or any kind of program. That means when we are writing a program, we are using some variables or some values at the time of writing the program, and some values are given after the program is executed, and at that particular time when that value is given, that must be stored in memory, and that kind of memory allocation is known as a dynamic memory allocation. So this area, the heap, is the area that used for reserved for dynamic allocation, and the stack is the area which is responsible to move the program or to move the total process into the CPU so that the CPU or the ALU is able to execute the process. So these are the different segment of memory that assigned to a process by the operating system after getting the executable file of that particular program. Now, once the process is getting all this kind of memory process, for the complete execution it is go through these 5 different states and the different stages. The first stage, when memory is allocated or when the computer, the executable program or the process enter to the memory, that particular state is known as the start state. After the start state, immediately the program become ready or it move to the ready states for further execution or further calculation or processing, anything you can term that. After the start process, start is the process when the process enter to the memory for calculation or enter to the ALU for calculation, and immediately after the program or the process is ready. Now the process is in ready state for calculation. After the ready state, what happened? The program enter to the ALU for any kind of arithmetical or logical calculation. And that particular time period is known as a running state. That means now the program is executing or processing or running, anything you can term for that particular what. Now this is the area where the program is actually executing. But in the last session I told you, sometime within the execution the program need to be used by the memory or need to be used by the input output. In that particular period, suppose some other program is entered to the CPU. I told you about multiprocessing operating system. When one process is using IO or memory or any other devices except the CPU, then the operating system enter or use another process or another job to be executed by the CPU. Now suppose the first job is in running section. Job 1 is running, and after 2 seconds of running of the job 1, the job 1 need 10 seconds of IO operation. It need 10 seconds of IO operation. That means still the program is in running state. Whether it is using the IO or it is using the memory or it is using the CPU, still it is in running state. Now it moves to the IO, that means the CPU has been freed now. Now what happened? The operating system enters job 2 for using the CPU. Job 2 for using the CPU, and the job 2 need 15 seconds for the CPU execution. Now after 10 minutes what's happened? Job 2 is completed its operation in the IO devices. But still the job 2 engaged the CPU. The job 1 completed IO in 10 seconds, but the job 2 still engaged the CPU because it needs 15 seconds to complete its execution. And that 5 seconds, 10 to 15, that 5 seconds, the job 1 is come to one more state that is known as waiting state or wait state. That means now job 1 has to wait for execution or for calculation or for getting the running state again. Now after waiting state, it again moves to the ready states, and from the ready states is the running state. Now this process continues, or this process may be repeatedly executed. The ready, running, start, ready, running, start 2 or 3 times, or it may be in one time. After completing the execution of the process or complete the execution of the process, the next state appears, that is the terminated state or terminate state. In this state the program execution has been completed. We got the output or we got the result. The result has to be written into the memory again, because whatever be the result we are getting from any process or group of processes, that must be stored in the memory. So in this state what happened, the operating system will again write the result or write the output into the memory. So these are how a process is executed by the operating system. First, the memory is allocated. First, different kind of memories are allocated for different purpose. After the memory allocation appear, it comes to start state, then start to ready state, then ready to running state. In the running state, sometimes it comes to wait state, again ready state, again running state. If there is no wait state, from the running itself it comes to the terminated state. So these are the 5 states and these are the 4 segment of memory allocation. So this much for today. Thank you and have a nice day.